4.6, fundamental theorem of algebra. Sounds pretty important. Fundamental theorem of algebra states that a polynomial with degree n has exactly n solutions. But not all of these solutions are necessarily rational or real. They can be roots, they can contain I, so they can be imaginary. But the degree tells us something about how many solutions we have. Example 1, let's see how many solutions do we have here. When we take a look at the degree, we can say it's a third degree. So that tells us we have 3 solutions. So the next question, well, how many zeros do we have? Again, you take a look at the degree, 4th degree. So that tells us we have 4 zeros. So for example 2, given a function, we want to find all of the zeros. Now, using our fundamental theorem, we can see it's degree 5, so we should have 5 zeros total. So just like before, we're going to list our rational roots. First number is 1, the last is 8. It's going to be plus or minus factors of 8. 1, 2, 4, 8. Over factors of 4, which is just 1. So our possible roots are plus or minus 1, 2, 4, and 8. Now, like you've done before, we can go through and start testing. We're going to use the graph of this to give us a little bit of help. So here's the graph of our function in example 2. I want to see how many of the zeros show up on the graph. Remember, when we have a bounce, that counts as a double root. And then we can see a single root there. So we can actually see 3 of our roots. So that leaves 2 roots we can't see, 2 that we need to find. Now this double root is something that can make the synthetic division a little more difficult. If it's possible, you'll have to use the same number twice. We can see it here, so let's use it. I'm going to do synthetic division to get down to where we can find the roots that do not show up. So just to write out the function so we can see if we're missing anything. 1 x to the 5th. We don't have an x to the 4th, so we say that's 0 x to the 4th. Plus 1 x cubed minus 2x squared minus 12x minus 2. So we're going to use the roots we know. Use synthetic division. That are the coefficients. This gives me my next set of coefficients. Since -1 is a double root, we're going to use -1 again with our synthetic division. And then these will be my new coefficients. Now I can use the other root I know and use synthetic division one more time. And these will be my new coefficients. Okay, so now we can write out the equation for this last piece, and the remainder constant to be an x, and this will be x squared. So that tells me I'm left with 1x squared plus 4. And then my other pieces of the equation I can get from my roots that I know. Let's say x plus 1. It's a double root, so it's squared. And x minus 2. So last step, we want to use the zero product property to find those last two zeros. So set this equal to 0. I already know from here and from my graph, x equals -1 is one of my zeros, and that's our double root. Now x can be 2. So I just have to solve x squared plus 4 equals 0 to find my last two. Let's say x squared be equal to -4. Square root both sides. So x is equal to plus or minus the square root of -4. So x is equal to plus or minus square root of 4 is 2. Square root of -1 is 9. So double root, single root, and then this is 2. So x equals 2i, and x equals -2i. That gives me my 5 root.